Well, hi, and thanks for joining me here in my shop today. I'm going to be goofing around some more with this radio and looking at response curves from it. I'll be a little more focused, I think, and really try to drive out the response curves so we can see them quite clearly. So I think the first one I'm going to go after, I'm going to leave the front end alone. I'm going to go after the IF response curve and see if I can't get that up on my scope. So let me just set everything up here. We'll get going on that. Okay, let's see how this goes. So what I've done is I've got the sweep generator sending a signal just a little below to a little above the IF frequency. I've got it fed into the antenna. The antenna is hooked essentially directly to the grid of the first tube, the mixer tube. And I have the scope basically connected to the output of the detector. So we can see kind of the ABC voltage if you like. So I think we're all set to go here. I just have to power this guy up. Yep. See what happens here. I'm putting out a fairly strong signal right now into the radio too. Maybe it's a little too strong. Let me just knock it back a bit. Okay, so the sweeper's not sweeping right now. Oh, yes, it is sweeping. Oh, you can hear a bit of a hummy buzz in there. No response on the scope. Scope is not in the right spot at all. Wait a sec here. Wait a minute. Yeah. Well, this is the response curve here. Now let me make sure the settings of the sweep, just to make sure it's doing what I think it's doing. The numbers are up here. Start frequency is I want it to be 440 kilohertz. Let's put it right on 440. And then the stop frequency, the top frequency should be 470. Okay, it's very close. I'm just making it right on. That should sweep it through 455. 455 should be dead center of the scope as long as I've got the scope centered properly. So that's about it. You can see that this curve is not very sharp. You can see it there. Not very sharp. Let me give it a little more signal. Input. Oh, it's actually very low. It's very low. Yeah, that's the problem there. Actually hadn't turned the input level up. See a little ABC action happening there. There we are. So there is the IF curve. And it looks a little bumpy to me. You know, I would imagine it to be a nice smooth thing, but instead it's got this bump here, and this bump isn't hitting the center mark, which I think is 455. I've set this up as best I can to make that 455, but I don't know for sure. Well, we got some stuff to do here. Let me fiddle with those IF cans and see if we can change the shape here. Just kind of at random, pick one of them. There we are. Okay, watching the shape now. Oh my gosh, look at that, eh? It should be much sharper. Let's just keep fiddling with it here. This is the next capacitor. Ooh. It's a little nicer, not right in the center. Other transformer now. And I think the thing about doing it this way is you become very sensitive to the shape of the curve, of course, but not so sensitive to its strength. It's easier on an indicating meter with a single frequency to get a maximum reading. But you don't know for sure you're getting the maximum reading with the right shape. That looks greatly improved to me. It still seems to be coming down from way over here. Nice to come straight across, and then more like this one. I don't know why it's dipping down. Gee, can I affect this little piece here somehow? Let's just go through more of these. I'll go through them again, watching that other side. And I've got both transformers in the mix here at the same time, which is probably a mistake. It's 4 adjustments here, all kind of inter-affecting each other. I think there's one here I haven't turned yet. You can kind of see as I turn this in one direction, you can kind of see the peak sort of travel along the line there, out the far side on the left, and then come back. So I can put that peak right on the money. Now, some of these kinds of things need to be done with logarithmic scales and logarithmic this and that, and so I just don't think I'm going to get any better than that, really. You know, so this could even be an effect of something kind of logarithmic. Now I can run my sweep in a logarithmic pattern here. Where'd it go? Well, apparently I can't. Yeah, I don't know what happened there. Okay, well, I really don't think I can do much better than that. Now, what can we tell what frequency these are? You know what? I'm gonna try to get us in a position where we can identify these frequencies. You know, it's actually yeah. Let's do that. Okay, so I've got the signal generator running over here. It's running at 456 on the numbers here. You got to add 1 or 2 to get the real number, so it's 457, 458. And what I'm going to do is I'm just going to hook it into the antenna with the other signal generator and see what we get. Now you might have been expecting some kind of a pip mark, you know, pip to show up. That's not how this works. What's happening really is the 2 signals are interfering with each other. And as I vary the frequency of either one, really, but the one I'm going to vary, of course, is the fixed guy, this interference pattern is going to move along the line a little bit. Wherever we max that interference is, well, let me do it. Talk. It's easier to see it. Traveling along. So I'm going to bring it right in, right on the dot, right on the, there we go. And now I can read the frequency up here. 452, add 2 to it, 454 is what this comes out to. Okay, that's good. Now what we really want to do is look at the curve and just examine some of the frequencies that are involved in that curve. Where'd the curve go? Okay, so there's the curve. I think maybe I can boost this a little bit here. Oops, wrong button. Boost it. So I can compete with the other guy a little bit. Let's see. So now if we're interested in knowing, let's say, where this curve starts coming down, to me it's right in this area. So I'm going to move the little wiggly thing. You see it's right here? I'm just going to move it over a little bit to the left there. Okay, so that's basically marking this vertical line, vertical graticule line. That's 443. I'm going to write this down. 4. So draw a line like that and put 443 plus 2, 445. Okay, and we'll find this point here. So you know, it kind of faded out there. Hey, what's drifting there? What was that? What's that little thing going on there? Why is this drifting back and forth a little bit? So I have it right up here. It kind of fades out as you get up here, of course. This is a response line. There's no response when you get up there. The frequency is 465 plus 2, 467. Okay. Now, some other spots to mark. Actually, these are, well, let's try about halfway down. So if we go halfway down, we'll just pick this line here, this graticule line. So that would be what? Okay, right there. 448. Okay, that was 448, and looking at the other spot, I would say that's about it there. So I'm looking at this line now. Did I do that the same on both sides? I must have. That number is 457 plus 2, 459. Okay, let's look at those numbers. See what this amounts to. Now, my diagram's not correct. I just wrote some numbers down here. So don't worry about the shape of the curve here. So we might imagine that the second part, you know, that's how it looks on the screen. Just like, the second measurement was here, 448 to 459. So how wide is that? So what's the difference between 48 and 59? That looks like 11. To me, 11 kilohertz. And then the lower part where it was kind of flattening out was 445 and 467. So that's about, well, that's 22. 22. Double 11. 22 kilohertz, you're definitely, you know, if there's an adjacent station at 10 kilohertz away, you're kind of sneaking in there a little bit. And this was about halfway down the line, about halfway down the curve. So, you know, that all adds up quite nicely to me. It really kind of says, hey, that's exactly what you want, I think. Now, is it really on? And what did I say it was on? 4? I can't remember what I measured that. Let me just check quickly here. What's it actually tuned to now? So it's 453 plus 2 is 455. So that puts 455 right in the middle. Perfect. That just can't get any better, I think. Great. Okay, now we can revert back to the front end of the radio and try to do something similar at the front end. Okay, so looking for a good spot now to look at the signal that's just either just arriving at this tube. No, sorry, this one. Or coming out. I tried the arrival thing, didn't go so good. So why don't we try looking at what is coming out of the mixer tube? Well, why don't we? Because the whole thing is an experiment. Pin 3 of the 12SA7. So we'll put the scope on pin 3 and we'll jam a sweep signal into the antenna here, and we'll see what shows up. Pin 3. Okay, 12SA7. Okay, 12SA7 is this tube up here, right down in the corner there. Pin 3, we want to be looking at pin 3. So we'll take the scope here. The receiver's off at the moment. So we want to get on pin 3 down here. 1, 2, 3. And I want to be on this ground. I think earlier I was doing, in one of the earlier videos, I had all my grounds on the chassis, and that was kind of a mistake, I think. 1, 2, 3. Now, I guess I better have the set operating when I make this connection, so we know what it's doing to it. Oh, good. Oh, excellent, excellent. There's a hole in the terminal I can clip onto. Beautiful. Okay, so we'll start it up like this and get it going. I got to set up my sweep here. So we want to sweep tightly. See, I had to sweep a little too broad last time. I was sweeping really from even below the IF frequency right up through and beyond. Let's try to tighten it up. You know, maybe I'll tighten it up right around well, let's tighten it up around 600. Since we've done so much at 600, why not continue? So I'll make it sweep from, let's say, 550 to 650. Okay, that's good. Let me just set this up here. 550 to 650. Okay, so this is the start frequency. $550. You know, as close as I can get it. 550. And this is the stop frequency. 550, 650. 650. There we are. 650 kilohertz. Good. Okay, now the next thing is, what is the next thing? The next thing is turn the radio on. Right, scope not connected yet. Now it's a chance. Oh, I haven't started to sweep. Start to sweep. There we go. If I tune the radio now beyond the sweep range, it should go quiet. So that other tone is, this guy's still going on the IF, so let's get him off. In fact, let's disconnect it to make sure it's not interfering here at all. That boosted the output of this one a little bit. It was being dragged down by this guy. Okay, volume up a little bit. Now, so I'm going to tune back to the 600. So now if I've done this right, the sweep is sweeping either side of 600. Now, interestingly enough, my frequency counter, terribly confused by what's happening with the sweep signal going through it, ends up kind of averaging it out. So you kind of see the middle, 599, 600, exactly what I was aiming for. So good job done there. Now I've got to get this up onto the scope. That's what's acting up. Scope connection, we were heading for pin 3 of the tube there, which I was all excited about because I found out I could attach this right here. Now there's a fairly high DC on here. I'm on the DC. I'm going to flip it to AC. And we're 5 volts, so it's insensitive. There we go. Okay, talking about insensitive. Certainly seem to have wiped out the signal that's heading for the so it's still there, just got knocked way down. Now I'm on the far side of a tube. There's no way this has interfered with the tuning at the front end. We don't need to listen to it. Ooh. Tune the radio a little bit. Perfect. Excellent. So with that peak sitting there in the middle, it's quite a funny looking thing actually. It's a very funny looking thing. I don't think you can you, maybe I can, let me see if I can get this a little better on the, there's some detail in there that's interesting. That's a little better. Hang on while I just adjust my camera there to try to improve the look of this. Oh, shoot. Okay, you gotta bear with me a moment longer while I have to recall up the camera control dialog box here. That's what I'm doing. I'm making stupid mistakes while I'm doing it. Okay. Let's try this now. There we go. Now it's become very jumpy on the video, but on my actual looking at this is a very, very stable picture here. And what I'm trying to draw attention to is the squiggly little thing going on just here. It's much more easy to see over here. It's a funny little squiggly thing. Who knows what that is? Now a good question would be, since like this shape is not at all the classic curve here, it's kind of out and drag and way out, and it looks like there's more than one inside there. How am I going to interpret that? So there is an out and back effect with the sweep generator. The sweep generator sweeps across and then shoots back. The shoot back is not blanked like on the old TVs. They used to blank out the retrace, or when you were heading back to the start. There's no blanking in here. So it's possible we're seeing a version, say, coming out, maybe that brighter one, and then a going back one, much higher speed. That's probably what this is. In fact, how could we prove that? I don't know how to prove that. We can slow the scan down, but I think everything's going to get really messy looking. Yeah. Really slow it down. That's crazy. That's not going to help anything. There's actually 3 of those. There's a little pulsy thing here. There's a fainter one right in here, and then there's another one out here. And they're very reminiscent of a second signal generator interfering. It looks like I've got the other signal generator going to some degree. Can I tune and see what those things do again? Tuning a bit. So they're traveling. Oh, that's very interesting. Oh, that's really interesting. So if I tune over here, that wiggly thing, I tuned it right so the wiggly thing is in the middle of the signal. What's this sound like? It's going to sound like that, unfortunately. You know what? That's right at the edge of the sweep. Is that all that is? On the other side. Oh, look at that. I think it's an artifact of the sweep. One at each end. Look at the change of the shape there. Now, you know what's going on? I'm probably moving through the sweep area. I have the sweep area fairly tight. Well, that's a good idea right there. I have it sweeping from Is it 550 to 650? Where's 550 on here? Let's go find out. Okay, I'm going to hook up the other signal generator. Good. And we're going to look for basically where's this peak. I'm going to move this a little more in the middle. Oh boy. Yeah, middle is the middle. I'll put it right there. Okay, and we'll bring on. It's a little hard to look at, isn't it? It's really shuttery on the video. Bring on the other signal generator. There it comes. So it just went through. So right now the other signal generator is right in this area here. That little squiggle you see is it. Now watch it, I'll move it across. It's really hard to see here. I'll turn this guy down a little bit. Okay, so that tone is coming from the fixed frequency signal generator. Can you read that? It's exactly 600 up here. Okay, yeah, you got us. It's 602 in fact. Really close. So that's 600. So I think it's right here. Let's just check. Yeah. So I'm marking where 600 is. 600 is on this line. I tune the radio to that line. Well, I'm not even. Well, that's interesting. I hear it here. Oh. Okay, so what's going on here? So the signal frequency signal generator is putting out 600, and the radios, you can hear it in the radio when I tune it. Right there. But the squiggly thing isn't right there. Now the squiggly thing is right there. 590. I'm not quite getting what's happening here. Is that an indication the front end is off tuned? Like the trimmer's not right? It's not quite what I expected here. Let's just think about this for a sec. Okay. There's my 1 second of thinking. And here there's another oscillation in there. Well, it's stuck here. I'm just kind of erased my plan. Okay, let's move this off. How do we know this is at 600? We learned earlier on that one of these marks is at 600 here on the radio. So this is 530, 550, and 600. It's dialed right on 600. Let's see if my sweep generator has drifted. It tends to do that. So we'll stop it. Start frequency is 550. Stop frequency is 650. That's perfect. It's 50 kilohertz either side of 600. So that's what this whole line is. 50 kilohertz. It's 100 kilohertz altogether. So this should be 600, 650, 550, 600, 650. Why is it not where it should be? Let me shrink the display here. I can center it better this way. So I'm looking at here and here to center it. It's 2.5, 2.5. So 600 should be right on the line now, and you can see this thing is not there. If I put it there, we're, well, you know, here's what's happening to the pointer. One of the things that it's important to keep an eye on, just how much is the pointer moving. So this is where it was, and this is where I would put it, here. So the difference between that and this. That, this, that, this, that, this. It's just not that much. It's like within the air, just dialing a frequency on here. So if I put the scope on if I put the 600 mark on the center line of the scope, and I look in here, we're just a hair low of the mark. And then if I check with this guy, what frequency are we really on? Let me stop the sweep here. Six, 15, 6, 16, 17. So that didn't work out at all, did it? Okay, well we should be able to see the output of this with the sweep running somewhere in there. Somewhere in the scope display. It's looking really ugly on the video. I apologize for that. Maybe I think I see it. I think I can see it right here. Well, that's interesting. Now that so you know, if you trust this display and you believe this is 600, 615 would be just out here. Misaligned front end. Is that what it is? I need to set the local oscillator properly. Exactly. Then I know for sure where the radio is tuned, or trying to tune, is via the local oscillator, and then I can adjust the front end tuning to match the local oscillator position. I'll try this whole thing at 600, and we'll try to prove the mark on the front. We'll try to prove everything. Prove everything. Okay, I'm going to prove everything under the sun. Okay, so here's what I'm trying. I'm always experimenting all the time. So this is normally used as a scope lead, but in fact I'm using it as the antenna input into my SDR radio. This is the antenna input. And although you can pull this back and clip it on something, I'm not even going to do that. I'm just going to leave the thing covered here so it can't make contact. I'm going to stick it in close to where it needs to go. Now, this whole thing's involved. It's not just a little tip. I'm going to stick it in here. Now watch on the SDR as I do this. You can already see the effect. The local oscillator will show right up. I'm just going to put it right in here. Try to put it right in here. There. Come on, stay put. You gotta stay in one spot for me to do this successfully. Let's try that. Somebody hold them down. Okay, there you see the local oscillator. I'll prove it by tuning the radio. Now you see it traveling back and forth. It's the strongest thing on the band there. You can't miss it. So now we want to set this radio to receive 600 based on the local oscillator. So we'll set the local oscillator to 600 plus 450, 1055. 1050. Let me put the red line on the SDR onto 1055 so I know exactly where I'm going. Turn the sound off. Well, we're extremely close now. So we go right past it there. Now that was interesting. Okay, so this radio, local oscillator, is attempting to convert a 600 cycle input signal to 455. That's what it's doing right now. It doesn't have a 600 input signal to do it with. I've left this one too close here. Let's get rid of that one. So now we really want to, well, we can see it actually. If I just flip cameras, you can look right at the scope. Think hard about this now.
Executed by the Department of Justice against your social insurance number. Ignoring this would be an intentional attempt to avoid initial appearances before the magistrate judge or exempt jury for a federal criminal offense. So before this matter goes to federal courthouse or you get arrested, kindly press 1 and speak to an officer now.
So in Canada, I don't know what goes on in other countries, in Canada everybody gets a call like that every day. Sometimes 2 or 3. Calling up and saying, this is the Canadian government calling, man, you're in big trouble, you better do this or you're going to jail. I don't know if that's going on in all countries, but boy, it's crazy here. Every day I get those calls. Okay, now back to what I'm doing. And what is it I'm Okay, right, so we got the local oscillator running, so the radio is trying to receive 600. We don't have any particular 600 signal there, except the sweep is going by. The point at which the front end is tuned is highlighted by the image on the scope. Okay, that's the easiest way to see the image on the scope. Now I've checked a couple times the sweep generator to make sure this is 550 and 650. Make 600 right in the middle. But the radio appears to be tuned to something other than 600. So, you know, I suppose what should be done now is you make an adjustment. Oh my God. Make an adjustment of the appropriate trimmer to move that tuning point over to where it should be, right in the middle. But there's a bit of a practical problem with doing that right now. Here it is. Now the practical problem is the tuning adjustments are now buried underneath here, and I've got all this stuff hooked up. How the heck am I going to get at that? I have to redo the whole shebang here somehow. Okay, stop the video and do the shebang. Redo the shebang. So you can see the local oscillator yellow line just disappearing off the bottom right there. And that is right on the money. It's ever so slightly off. Let's get it right on the money here. Now the SDR itself has frequency problems. I've got the SDR set to 1055, but if you look in the left panel, there's a frequency correction thing which is right. Oh, appears to be grayed out. OCW shift. Wait a minute. Right here. This number. This is a shift number, or compensates for inaccuracies with the SDR. It's kind of like an alignment, if you like. So we can't even be absolutely sure that this is 1055 on the thing here. We can't be absolutely sure. Sure enough, though. So that means tuning. Right. So let's go back to the other display. So the name of the game now is move that little bump right onto the center line. Okay? That would be. Now what I'm doing is I'm going to adjust the capacitor on adjust the trimmer on the tuning capacitor. Okay, here we go. It didn't go anywhere. Okay, so it moved a little. Did you see it move just a little? But you know what? I can't get there. So I'm tightening it. It's moving to the left. You can hear it getting quieter too. And then I'm going to open it up the capacitor, the trimmer. That's about as open as it can get. We're not quite on the center line. That's reducing capacitance. Now, don't dare retune the radio. So okay, so yes, I do dare to retune the radio. So let's do this another way. Let me put this capacitor back in a little bit. So it's got some bite. Okay. Now we know the local oscillator right now is where it should be, but the radio is not tuning where it should be. So I'm going to tune the radio, put that right in the middle. I'm turning the main tuning control on the radio. Now I'm going to take the local oscillator adjustment and move it. So on the SDR we're back to 1055. Okay, so I got to flip to the SDR here. Okay, so now you can see the red line, which doesn't appear red on my screen here, but let's say the yellow line. The yellow line looks good. Just to the left of it is a red line, which isn't red on my screen. Hopefully it'll be red on the finished video. So we want to adjust the local oscillator now to align the local oscillator with the red line at 1055. Okay, so we're going into the local oscillator. Trying to move it. Oh, that went the wrong way. That's pretty interesting because it got really loud there, but not right at the right mark. Let me put it back to 1055. So I can see on the scope here that the tuning point is dead center of the scope. The image is just slightly off. Let me just move it. It's just not quite centered right. Now the tuning point is ever so slightly off. Let me see if I can adjust it this way. Yeah. Now let's find out if we got this right on to 600. I'll bring in the other signal generator here. We'll see if the radio's really tuned to 600. So by my estimation, I'd say we're tuned to 604 right now, not 600. So this could be starting with problems with the SDR frequency. We can check and calibrate the SDR. Let's do that next. Check and calibrate the SDR. When I'm using the SDR, I have another SDR I use for shortwave. They're really cheap. The one in here is really cheap, $25 radio. The one I use is also a $25, $30 radio. They got a lot of problems in them. So they're not the best receivers. So I know there's a signal. Turn this guy down. We don't want to listen to this radio. We want to listen to the SDR. That on. I go down to 640. Actually 590. Why don't we do this at 590. So there's a station there. Now I've got to stop the sweep. And Do we hear any radio? I haven't got much of an antenna on this thing, that's for sure. Let me be the antenna here. Not good enough antenna. Let me try it this way. There we are. Okay, so I just need a little piece of wire to put this on for now. So I'm going to use the 640 AM radio signal. Come on, you gotta be here. Really? Okay, well, if I gotta be part of this, can't say I've ever done this before. This looks pretty stupid. Oh, what do I dare touch now? Well, it sounds pretty good. Now, let me just adjust it. How do we know when this guy's tuned in? Okay, so what we do is we expand the screen, expand it, expand it. So here is 640 now. This part here. See, just almost dead on. Or 590 rather. 590, almost dead on. This isn't the right control. I'm adjusting. For crying out loud. It's this guy up here. Okay, wasn't much of an adjustment, but now it's dead on. So when this says 590, it means 590. Okay, now we want to shrink this back down. We should continue with 590. There's no reason to. 600. Okay, let me disconnect myself from the circuit here before I end up in big trouble. Stick the probe back in. Okay, back in you go. Just up in here somewhere. Just lay in there. So what do we see on the SDR here? See, oh wait a minute, there's a change I gotta make on this, I think. That didn't help. Okay, I'm gonna turn that. Right, the sweep isn't running. That's what's going on. Let's put the sweep on. Nothing at all on the SDR. A little wee bit on the. There we are. So in this case now, the peak, according to the SDR image, the peak is a little to the left of 600. Now, let me think hard here. 600. The radio's tuned to 590. The radio's tuned to 590. Oh my god, I've lost control of the whole thing here. I've lost control of it. Too many things going at once here. Then I started thinking about what I'm doing right after I finish this. That's what happened. Where are you, signal? See it, you can definitely see it on the SDR. So I've lined up this signal generator on the red line on the SDR, which you cannot see at the moment, at least on my camera. Oh, look at that, 600. So that's proof that the SDR 600 is agreeing more or less with my signal generator over here, 600. Radio oscillator. Oh my gosh, I think I can barely. Where is it? Oh, it won't be on the screen because I got this thing expanded out. Right. Unexpand. Okay, so the local oscillator, unexpand. There's the local oscillator. So we'll check the frequency of the local oscillator here. Right on 1055. And this looks like it's right on 600 now, but really there's two things here. There's the curve, and then there's the 600 signal I'm sending from the other signal generator. I can get rid of the other 600 signal generator, look at the curve, and then try to adjust the curve right on top of this, and we're done, I think. Okay, let me get rid of the other signal. And since we know that's correct, I'm gonna move this red line here, and then I'm gonna expand. Okay, so just gotta move that little peak over to the red line. And if I did it right, I set the screw in a position where it can work in both directions from here. Just going over. I'd say it's there. So I'd say now the local oscillator and the front end tuning are all aimed at the same frequency of 600. This should maximize the performance of this radio. 600. Now the right, so if we want to check now to see how sensitive the radio remains to a image signal, because I have the feeling its sensitivity has gone way down, I can ram in the image and see what we can see. So let me turn off the sweep here. Turn up the radio. It's pretty quiet because it's got so much stuff hooked up to the antenna. I can yeah, there's well, let's just go try. It was the frequency was 1510, I believe. 1510 will interfere with 600. 1510, eh? Let's see. Well, it's 1700. Did some terrible calculations. $1,700. How does that happen? Wait a minute. Hold on, everything was going great, and then suddenly things stop adding up. So we're at We're at 600. Local, I got a chart on this already. You have to write it down. We're at 600. Local oscillator at 655. 1510. Did I do something stupid here? 1055. 1055. And add 455. No, it's obvious. It's 1510. 1510. But I'm hearing it at 1717. And the radio's definitely tuned to 600. And the local oscillator is sitting at, well, I don't have it on the screen at the moment, but well, I can say this: cannot hear anything at 1510. Turn up the radio a little bit here. Nada. My radio's just doing its own thing there. This is 1670 now. I just turned up the radio. What? Wasn't it up there? Okay, let me change the volume setting here. Oh. Yeah, the volume control is a little dirty, so. Okay, so that's full volume. Let me turn it down. Still there. Maybe I don't know what happened there. In any case, it's not 1510. What could it how could this possibly happen? I don't know, but it is happening. It is happening. Okay, well, leaving that anomaly aside, I'll just disconnect everything. Let's play this radio and see what it sounds like. Okay, power off. Disconnect the various guys here. Of course, I'm disconnecting all this stuff. The radio is adopting a new tuning situation. No, that's not really true. And we like to put this on the outdoor antenna. So I'm pretty sure I have switched not into this room. But that's a lot of wire. Just the lead to the antenna is a lot. Even if it doesn't actually make it to the antenna. Okay, stop the muttering. Okay, let's put this guy into normal position here. Go. Okay, man, this is your chance, Mr. Radio. Your chance. Volume down. Volume control problems here. Go down all the way. It's just some dirt in there. There we go. Sweep generator is running. Let's stop it. Oh, stop it. Stop it. Won't start it. That's not very interesting to hear. So we just moved off the 600 and got 590. Now, hear that tone? It's really sharp now. The pitch doesn't change. So that's an interfering adjacent noise signal causing an accidental production of a tone out of the detector. That's probably out of the mixer detector. Out of the radio anyway. So you can't do much about that. Last time I hooked up the ground, the thing really improved. Let's try that. Yeah. That's better. When you're testing a radio like this, you're testing the antenna at the same time, and you can't be sure just which one is. It's very good. It's picking up stations you don't normally get. Excellent. Well, that exercise and lining those things up, I think, has made quite a difference. And I'm not sure I can get to this point with a radio without doing all that malarkey. Just doing the straightforward alignment as guided through the instructions doesn't quite get you there. It left me with a funny shape in the IF response curve, and I ended up with the front end not tuned right on where the local oscillator was targeting, and I had the local oscillator in the wrong spot a little bit. Everything kind of out of whack using the usual technique. So I'm pretty happy with this result. What I'm going to do is I'm going to put a much better loop antenna on here, and we're really going to give this radio a shot. This is your chance, radio. This is your 15 minutes is coming.
Sportsnet 590 The Fan. Listen live at sportsnet.ca/590 through the Sportsnet app or the Radio Player Canada app.
Nothing to prove. I'm Andrew Dye with this Sportsnet.
Okay, so the antenna we're using now is this loop antenna that I made this when I was in college. It'd be 1976, I think. Look, it's just broom handles. It's all random. I only had so much wire. There's nothing spectacular about this except it works. And here I am so many years later. I have dragged that thing with me all the way to here. Now that antenna I just showed you is a tuned antenna. It's not tuned yet, so
Still in the next generation. There's Webster on leadoff this
I will tune it. We'll listen to that and I'll tune it.
Tomorrow against Brooklyn. Maple Leafs will practice in Edmonton at 2:30 our time, fresh off that 4-2 loss in Calgary. Johnny Gaudreau tied the game 19 seconds into the third. Flames would add 2 more before the 3-minute mark. Leafs also came up empty with 1:34 of 5-on-3. Coming up in minutes, the Argos will unveil Ryan Dinwiddie as the 45th head coach in franchise.
Now that antenna has a response curve, as has one of these, and it's quite sharp. And maybe get a range of 4 or 5 channels either way without having to go back and retune it. Let's go down on it.
Before a late rally,
I'm going to tune the antenna. So this radio's become really hot here.
oh, way to go out on a Friday.
Says she never had such a horrifying experience in her life, but she commends the team staff for their quick action.
Sunday the 15th, airlines flying to, from, and within Canada will have to compensate passengers up to $1,000 for flight delays. To make your way just through Parkland and Parkside.
Okay, let me retune the antenna now.
Le
Marc Garneau. Enfin, les mesures qui devront être mises en place par les grandes compagnies aériennes lors de ces retards prolongés.
Pour nous, c'est 3 heures, avec un besoin de bien traiter les passagers durant le temps qu'ils sont de l'eau, avec de la nourriture, avec des communications, avec l'accès aux toilettes, avec des messages réguliers pour leur dire ce qu'il y en est de la situation, avec un système de chauffage et air conditionné pour qu'ils soient confortables. Ces choses-là sont mises en place.
I had to turn the radio down.
Les transporteurs devront aussi offrir aux parents un siège à proximité de leurs enfants de moins de 14 ans sans frais supplémentaires. Le premier volet du règlement était entré en vigueur en juillet dernier. Une compagnie de taxi de North Bay fait appel à des étudiants pour créer une nouvelle application pour gérer des appels de service. Au lieu de faire appel à des...
Now, hear the tone? Hear that tone?
50 Cab a demandé à des étudiants informatiques à l'université d'EPC...
Is it remaining the same pitch? Just an adjacent noise signal causing that, not image signals. Well, this radio's performance is sky high. If we pick anything up here, I'd be stunned. Okay, let me tune the antenna up. Very sharp tuning. You could hear it. Nobody home though. Well, great exercise there. Wow, I think I've probably done a better job with this radio than almost any other radio. Now, I've done this kind of alignment quite a few times now where I use the SDR and try to get everything. You know, you're trying to adjust 3 factors that are interdependent. That's the problem with doing this stuff. At times you're adjusting 3 factors. So, okay, that's great. I got to get going. I got to get going on my next thing today. So thanks a lot for watching, and I think I got to get another radio at this point. At least put this guy back in his cabin. Bye-bye.